Rotational Kinematics. So remember our kinematics equations from way back in Unit 2? Whoa! What did I do there? Well, all I did was go through and take every translational quantity and replaced it with its analog in rotation. Lo and behold, the first two there are on our equation sheet. The third one's not, and here's my theory on why. So this little delta theta at the bottom here is not truly final minus initial angle. It's really the total angle change. So 2 revolutions equals 4 pi radians. But that's really hard to put on an equation sheet, so I think they just left it out and left it to you to remember that all of rotational kinematics and all of rotation is just an analogy to translational motion. Remember, it's all the same, but now it's all Greek to me. So really quickly, if we have vectors, we do have to talk about direction, all right? The counterclockwise direction is going to be defined as positive. Couple of warnings when using rotational kinematics. Okay, we've talked about centripetal acceleration in uniform circular motion. You can still have centripetal acceleration that's pointed towards the center of rotation. That's what's affecting the direction of whatever's moving, so especially if something's going around the edge. Now, your tangential acceleration, hence the subscript here, which is a little blurry in this picture, I know, I'm sorry. All right, but that affects the magnitude of your tangential velocity. Out of your OpenStax book, here's a little chart that matches up your rotational and your translational equations. Please do remember that in all of these equations, in kinematics, we needed a constant acceleration. Our acceleration could not be changing. So that's the same here in rotational, except now it's your angular acceleration that has to be constant. Some problem-solving strategies. I know this is small. It's straight out of OpenStax, so if you want to go look at it, this is in the section from Rotational Kinematics. I want to point out a couple of things. This looks a lot like my problem-solving strategies. Please remember a sketch, especially when we're talking about rotation and there's directions and angles. A sketch can be very useful. Remember to use your translational analogs, okay, to think of the equivalent equation or quantity in rotation. And remember that when you're doing angles, we're working in radians, not degrees. So check your calculator if you think you got a funny answer.